The question is saying that if a solenoid in exercise 5.5, it is talking about the previous exercise, is free to turn about the vertical direction and the uniform horizontal magnetic field of 0.25 Tesla is applied, what is the magnitude of torque on the solenoid when its axis makes an angle of 30 degree with the direction of applied field? Now, previously we saw that there was a solenoid of 800 turns in which the current was flowing in the solenoid, and it has a cross-section area that was given. Now it was not subjected to any external magnetic field. Now in this question, that solenoid is subjected to external magnetic field of magnitude 0.25 Tesla. So we can assume the problem to be like this: magnetic field is from left to right direction of 0.25 Tesla magnitude, and the solenoid is making 30 degrees. The axis of solenoid is making 30 degree with this magnetic field. Now we have to find out torque on the solenoid. Now we know that torque on a magnetic dipole in the magnetic field is given by tau equals to mb sine theta, where m is the magnetic dipole moment. Now here solenoid will act as a magnetic dipole with the given magnetic dipole moment, and b is the magnitude of magnetic field, that is 0.25 Tesla, and sine theta, where theta is the angle between the solenoid axis or the magnetic dipole and the magnetic field, external magnetic field. Now based on the previous data, we have the magnitude of magnetic dipole moment, that is 0.6, and we have been given the magnitude of magnetic field, external magnetic field, that is 0.25 Tesla and sine 30 degree. If we substitute these values in this formula, we will get the value of torque as 0.075 Newton meter. Thank you.